a special number associated with matrices, and that's called the determinant. The determinant is a real number, and it comes from a square matrix. So in a square matrix, when we talk about the real number associated with the square matrix, it's called the determinant. There's a lot of applications of the determinant once we get into some other topics involving matrices. And those of you that move on to linear algebra will need to be able to calculate the determinant for other operations as well. Just some notation. We're just going to do the determinant of a 2x2 and a 3x3 matrix. Obviously, you could do a determinant for a 4x4, 5x5, etc., but it gets to be very tedious by hand. And I'll show you how to do it also on the calculator. Just some notation when we talk about the determinant. Again, square matrix, remember from the other day, a square matrix has to have the same number of rows and columns. So you can only find the determinant from a square matrix. You may see the abbreviation DET with the uppercase A. That indicate we're talking about the determinant of matrix A, or whatever the name of the matrix may be. Or what looks like the absolute value bars, it's not. This is your notation that you may see around a matrix. It does not mean taking the absolute value. A determinant can be a negative or a positive number, but this is just a notation you may see when we're talking about the determinant. All right? So let's talk about the 2x2 matrix first. To find the determinant of a 2x2 matrix, it's the difference of the products of the entries on the diagonals. So for example, what you're simply going to do to find the determinant of a 2x2 matrix is you're going to multiply the product A times D together, and then you're going to subtract from that the difference of the cross products C and B. So pretty much tic-tac-toe, yes. So that's how you find the determinant of a 2x2 matrix. So 2x2s aren't too hard to do. The determinant of a 3x3 matrix. Again, what you're going to have to do to find the determinant of a 3x3 matrix, first of all, is you're going to have to repeat the first two columns to the right of the matrix, or to the determinant. So what I mean by that is this. Here's my matrix, we'll call this matrix A. And I have the entries labeled A through I. So what you're going to have to do to calculate the determinant, first thing you're going to do is you're going to recopy the first two columns right next to this matrix. So A, D, G, B, E, H. So you just recopy. Draw diagonals. Kind of like I did with the 2x2. From A, B, and C downward, and G, H, and I upward. So what I mean by that is this. I'm going to go diagonally, and I have to find the product of A times E times I. I'm going to add that to my next diagonal going down, B times F times G. I'm going to add it to my next diagonal going down, C times D times H. So I'll do this, that's why I said the 3x3, that's why we won't do anything larger by hand than a 3x3. Then what you're going to have to do is you'll subtract it. Now you're going to have your diagonals going upward. So starting down here in the bottom left corner, you'll subtract it from the product of G times E times C. Next diagonal will be coming from H, F, and A. Add it. And then the next one will be from the last one, I times D times B. It'll be a little bit easier to see once we get the numbers in there. Again, like I said, you can only find the determinants from a square matrix where the number of rows is equal to the number of columns. It's a special number associated with a square matrix. And we'll get into some other applications of the determinant later on. All right? Yes?
So we're talking about why it's defined that way or how it comes out to that?
You know, I've never seen where it really comes from. I don't think I've ever really seen where it comes from. Probably could do some investigation to find out, but there's very little about the determinant out there. Okay? So again, like I just said, step 3, you subtract the sum of the products in the upward slope, upward diagonals, from the sum of the products in the downward slope, as I just kind of wrote out for you. So finding the determinant of the matrix. So for example, in example 1a, this is a 2 by 2, so you don't need to recopy any columns over again. So what I'm simply going to do is I'm going to take the cross product of 2 times 4, and I'm going to subtract it from the cross product of 1 times negative 3. So then 2 times 4 is 8, minus a negative 3, which gives me 11. So that's your determinant. So then in B, going downward, negative 1 times negative 4, minus 2 times 2. So I end up with 4 minus 4, which gives me 0. So any questions on how you find the determinant from a 2 by 2? So now let's go ahead and do the 3 by 3. So first thing you need to do is you need to recopy the first 2 columns. So here's my negative 1, 0, 3, 1, 2, and 4. So what I'm first going to do is I'm going to calculate the cross products of the diagonal going down. So I have negative 1 times 2 times 2. Add that to my next product going down. 1 times 3 times 3. Add it to 2 times 0 times 4. I'm going to now subtract that from the product of the diagonals going upward, starting in your lower left corner. So I have to subtract it from the product of 3 times 2 times negative 1, plus 4 times, wait a minute. Oh shoot, I circled the wrong one. It should be 3 times 2 times 2. I circled the negative 1, but it should be 3 times 2 times 2. I knew something went off. So that's going to be 4 times 3 times negative 1. And then add that to 2 times 0 times 1. Okay? So then negative 1 times 2 is going to give me a negative 4 plus 9 plus 0. Minus 3 times 2 is 12. Minus 12 plus 0. So what is the determinant of this 3 by 3 matrix going to be? It's going to be a 5. Okay? You guys go ahead and try D for me on your own.